Hello everyone, happy Thursday. Today we started our new lesson, lesson 21, and we're working with fractions on the number line. My kids were already familiar with it because we have been working with that for about maybe 2 weeks now. So when we started this lesson, they jumped right on in and they understood the lesson and they had no problems with it. So you can almost say like today's lesson was a little review for them. So we're gonna go ahead and go on and get started with the first problem. So vocabulary, I did that with them in class already, so you don't have to worry about doing that. So we're gonna start at number 2, and homework pages today was 473 and 474. So number 2 says, on the number line below, the whole that is between 0 and 1 is divided into equal parts. Okay, so we have a whole. This whole thing has been divided into equal parts. That's what they're saying. This whole shape is divided into equal parts. And it's between 0 and 1. Okay, it says label each part of the area model with the unit fraction it represents. Okay, so unit fraction is one of our new vocabulary words for this lesson. And unit fraction is basically a fraction that has 1 in the numerator. So then you might be saying, Ms. Newman, what is a numerator? Okay, so we also discussed that in class 2. That is a new vocabulary word. The numerator is the top number on your fraction. It is above the fraction line and it tells you how many parts are shaded in. Then we have our denominator, that is the bottom part of our fraction or below the fraction line, and it tells us the total equal parts. That's the kind of definitions we're using now. I know there are more technical ones, but those are the ones we're using to where they can understand it a little bit better. So those are the 3 definitions that we're working with today: numerator, denominator, and unit fraction. So again, a unit fraction is a fraction that has 1, the number 1, in the numerator. So they asked us to label the unit fractions. So first we have to figure out what this number line has been broken up into. All right, so let's see, we count the spaces, not the tick marks. And when I say tick marks are the little lines in between 0 and 1, or little lines here you see, we call those tick marks. So you count the spaces in between, not the tick marks. So if I count the spaces in between 0 and 1, there will be 1, 2, 3. 3 spaces, and I'll label it on top so you know when I'm counting. This is 1, 2, 3. 3 spaces. 3 are 3 parts. 3 parts means this number line is in thirds, because 3 parts means thirds. So when I do my unit fraction, I'm going to put my unit as thirds, but remember to put your 1 in the numerator, because that's what makes a unit fraction a unit fraction. So for this piece right here, it's going to be 1/3. For this one, it is also 1/3. And this one is 1/3. Each one of these little pieces equal 1/3. That's how big it is. It's 1/3. Now, I know it just asks us to label the unit fraction, but in class, I make the kids label the fractions at the bottom as well on the tick marks, just to get them in a practice of doing it. So I'm going to do it right quickly too. Now, for the first tick mark, we start here. That is going to be, because this is in thirds, this is 1/3. Then the next tick mark is 2/3. And then the next tick mark is 3/3, and that's 1 whole. Because that is 1 whole shape, 3/3. Okay, so that is it for number 2. We're going to go ahead and go to the back side of the sheet to number 3. Okay, so let's look at number 3. Number 3 says you can count fractions on a number line just like you can count whole numbers. So usually when we see a number line, you have whole numbers on it. It can start at 0 and it can go 1, 2, 3, 4, 5, 6, and it goes on forever. Or it can skip count by certain numbers. You can skip count by 5. So you can start at 0 and go 5, 10, 15, 20. It depends on whatever you're counting by, your number line can go by. Well, that's what they're trying to say. We have a number line, and usually we count by whole numbers, but you can also count with fractions on a number line. So 8 say, fill in the blanks to count the thirds below. So it starts with 1, 2, 3, and then we have the little dots. That means it'll continue on forever. So they want us to fill in the blanks for the missing numerators. Okay, so we have 1/3. The next fraction would be 2/3. Then after 2/3 comes 3/3. And then they actually stopped the count there with the little dots because it'll continue on forever. And I'm assuming they stopped it at 3/3 because one whole, we usually, right now we're looking at fractions that kind of stop at one whole, and we usually stop at 3/3 because 3/3 is one whole. All right, so let's go to B. B says, now count the thirds on the number line. Finish labeling the number line by filling in the missing numerators. So when we go to the number line here, our number line starts at 0, ends at 1. In between, we have our unit fractions on top. Because there are 1, 2, 3 parts, this is thirds. So we put the unit fraction of 1/3. 1/3, this piece equals 1/3, this piece is 1/3, and this piece is 1/3. Now, under here, we're gonna write the count of the fraction. So we start at 0, and then we go to the first tick mark. This is gonna be 1/3. Then we're gonna go to the second tick mark. This is 2/3. And now when I go to the next tick mark, it's 3/3, it's already there, but notice it's one whole again. All right, let's go to number 4. Number 4 says you can also use number lines to show fractions greater than 1, okay? So sometimes your number line can go past 1. Complete the number line below by filling in the missing fraction labels. So let's look at the number line. The number line goes from 0 to 1, that's just like that one, but then it goes from 1 to 2. Well, in between those whole numbers, we have parts. So between 0 and 1, I have 1, 2, 3 parts. So this is thirds, that's why it's thirds. So when I go to this one, between these two whole numbers, 1 and 2, I have 3 parts as well. That's why it's thirds here. So we're not looking at the whole number line from 0 to 2 when we're looking to see how many parts. You're looking at between whole numbers. Between 0 and 1, I have 3 parts. Between 1 and 2, I have 3 parts. That's how you know it's thirds. Okay, and they already put our unit fraction, so each one of the little pieces equal 1/3. Now, at the bottom, they want us to write or label the missing fractions. So it starts at 0/3, then it goes to 1/3, then 2/3, then 3/3, which is my one whole, then it goes to 4/3, then 5/3, and it ends at 6/3. And then that is the completed number line. All right, let's go to the last problem, which is number 5. So number 5 says, let me erase this. Look at the fractions on the number line in problem 4. Why do you think the numerator is twice the denominator in the fraction that names 2 wholes? So this is what we're looking at. This area right here. Why? Let's put the fraction. I'm gonna quickly rewrite the fractions because I had to delete it. So they want to know, why do you think the numerator is twice the denominator in the fraction that names 2 wholes? So when we got to 1 whole, one whole had a numerator of 3 and a denominator was 3. That's because if we had one whole shape, say I had a rectangle, and I put that rectangle into thirds, 3 parts, and if this rectangle is one whole, because it's one whole rectangle, and I put it into 3 parts. So if I have 3 equal parts, this is thirds. Now if I shade in all 3, then 3 of the thirds are shaded in. That means the whole shape is shaded in. So that's why 3/3 and 1 whole is the same thing. That 3/3 lets me know that all my parts in my shape is shaded in, the whole shape is shaded in. That's why 1 whole shape is shaded in. That's why it's 1 and 3/3 are the same amount. Well, now they want to know, why is it that the numerator doubled when it got to 2 wholes? Well, let's look at that. If I drew a rectangle again, and I'm trying to get it the same size because when we're looking at shapes and fractions, we want to get it as equal as possible so we can compare them. Again, this is another one whole shape. I have 1, 2, 3 parts. See how my denominator did not change? Same denominator as this one. But if I shade in all 3, now if I count them all together, this is 1 whole and this is 2 holes. So I'm going to put 2 holes now because I want to put my shapes together. This is 2 holes, 1 hole, 2 holes. Well, if I look at this and I count how many are shaded all together, since I put them together, they're going to be 1, 2, 3, 4, 5, 6 thirds. So they want to know, why did it change? Because, let's look, why do you think the numerator is twice the denominator in the fraction that names 2 wholes? Because now we have twice the amount of thirds. We have 6 oh, I'm sorry. I got a little tongue tie right there. I have 6 pieces that are now shaded in. And that is out of 2 whole shapes. So let's answer the question. I'm going to reread it again. Why do you think the numerator is twice the denominator in the fraction that names 2 wholes? Because if we have 2 whole shapes and it's put into thirds, when we shade in all of the parts, we will have 6 parts shaded in. Okay. And also you can look at it, 1 whole is 3/3, but I have 2, so it just doubles. The numerator doubles, but the denominator doesn't change because remember, that's how many parts we have inside of our fraction. Inside of our shape. So this doesn't change to 6 pieces because I don't have 6 pieces on inside of this shape. I only have 3. So that denominator stays in 3, but we count all the numerator, all the shaded parts together. So that would be 6. All right, that is it for today. If you have any questions, comments, you can also always send me a message on PBIS or put a comment in the comments down below. We are going to have another lesson on tomorrow, so I will do another homework video on tomorrow, and then we're going to continue this into next week. That is it for today. I will see you guys on tomorrow. Bye.